the microphone on? Is it working?
Yes.
Okay, so I'm going to, just a quick about the presentation. I noticed some people did the about presentation. One of the things I'm doing my presentation in is InSuite, and all of the slides, I use a system called Office Objects where all the slides are persisted in an object database. There's no mapping, of course. And then most of the user interfaces you'll see today are naked objects user interfaces. So I'm going to open up a Suite stopwatch and drag the activate message and click that, and my timer is started. So now I'm going to go to my slide presentations. Open this up, accessing the database. Hopefully everything is fine. We have a video issue. And here's my talk. Close that. Today I want to talk about location-aware networks, context, and business intelligence. It's three small talk systems. A telecommunications platform called the Awareness Engine, a business intelligence module called Tephra, and these are both tightly integrated to a geospatial domain persisted in the object database as well, which I haven't named. I have a picture of South Africa on the slide because these systems that's where these systems are currently running. There's an organization in South Africa called Childline. And Childline is an organization supporting the entire country that helps young folks who may be dealing with issues like teen pregnancy or domestic violence or maybe a crisis situation. And there's this phone number that's a national number, 800-055-555, which they can dial, and that connects them to the nearest Childline office to their location. This is accomplished via a telephone system that Vodacom has had for a long time called the 125. It's actually a specialization of it because you don't have to dial 125. We've got that fixed number that I just showed you. But what the 125 service lets you do is dial 125 and a key plus a keyword on your phone, and you can be connected to whichever party is registered for that keyword, its nearest location. Since the 1990s up until 2008, this system was implemented on an INR system, Intelligent Network Routing, which was, because of its age, was very expensive annual contracts. It was $1 million a year for Vodacom to maintain this system running on tandem computers. So they wanted to replace it with a more modern system that was actually from 40ST, the company I work for. But the reason it says OpenWave is because they're the preferred vendor. So it was their system, but it's really ours. And our system is the Awareness Engine, which is a generic platform on which multiple applications can be built. In this case, a 125 system, which we call dialed access location. This offers a much simpler and more forward-looking architecture because we can run any kind of application we're using Smalltalk. And there's the service chain of how, by the time we got paid, I think we made almost minimum wage. Here's the company made, the principles of the company. It was founded in 2008 by Brent Pinkney. Many Smalltalkers know him. John Sullivan, the CEO, they hired myself and Dr. Andrew Gaylor later in the year. Here's the original architecture of the INR system, the legacy system. And as you can see, there are basically 12 steps when the 125 service is used. It has to go through these two bridges, the Synap Camel Bridge and the TWLI bridge. With the Awareness Engine, we don't have those two bridges. The Awareness Engine can talk directly to the NSC. So what is the Awareness Engine? It's a new kind of element on the network that allows the position and movement of all subscribers to be monitored all the time. It's a server-side app, so a smartphone is not required. The system there's a lot of information that's created whenever you use your phone. Your location, device, activity, time. There's also other things that were collected when you created an account with the mobile provider. What the grand vision of the system is, the Awareness Engine, is to be used in combination with the business intelligence system to eventually by aggregating data, eventually be able to infer certain attributes of the members. And the awareness engine is a very scalable system. When we talk about scalability, usually we think about scaling large, but in many cases, it's actually more difficult to scale small. Once you're large, you can't scale small. If you're small, you can probably scale large. So a moment ago, I said it tracks the movement of all subscribers all the time. How could that be possible? Obviously, particularly with a dumb phone. I mean, there's no way that we're going to pull all the phones and get their location and try to update the system. The way it works is a little program that runs on the SIM chip of the phone. It's a little program that wakes up every 60 seconds, extracts the current CGI for the cell location that it's in, stores it in a TPROM memory, and if it's different, send that to the awareness engine. And that way, the system only gets the deltas of the changes in position for all subscribers. That's still a lot of data, but because we're receiving all the information for a location, we can have a very simple object model. We have a couple of network classes and location classes and subscriber. This is part of the domain. And in particular, there's a position table that has one row per phone number. And the last known position for a subscriber can be retrieved in a single operation and updated as well. And with a foreign key to the zones, we can also get all subscribers that are in a particular zone at a particular in a single operation. So on this generic telecommunications platform, we have built or can build many novel revenue-generating applications, like these ones are related to safety. Safe child alerts lets parents define a geographical zone and be alerted if their child leaves it. Enhanced emergency services for maybe $10 a year. My wife and I can register our phones, and if either one of us ever dials 911, the other will receive a text message with the location of the person who dialed 911. Remote voice witness, perhaps if you get pulled over by the police in South Africa, you might want to just press a couple of buttons on your phone. It becomes a recording device, and you capture the conversation, and you press one button, it sends it as an attachment to your email. Some other applications, short location service, just press one button to send your location to another person. What the next logical thing that follows from that is maybe you might want to receive notifications of locations of your friends in your social network. And then the big kahuna application that was the grand vision for conceiving the awareness engine was the mobile marketing application, where you can sign up and express interest in various kinds of services, like theater merchants can then also sign up and submit campaigns. And then if the show's about to start in a couple of hours and they still have half the theater open on a Wednesday, they can send a campaign offer to all in the area to say, right now you can get 50% off this show. So that's the type of vision. And a few more: mobile integrated syndication, receive stock quotes, and headlines on your phone, intelligent broadcast notifications. Perhaps when, that's a first. Intelligent broadcast is for when it's a fixed location, like when you arrive at the Beau Rivage, maybe you get the hotel would want you to get a message on your phone, welcome, see the casino guy for free chips or something like that. And there's more applications that are very trivial to develop. One of the things that's the goal of this is that one of the mobile operators are facing over 100% saturation. So they're not really able to grow their subscriber base anymore. There's more phones than people. So that's one of the goals, is to find other ways of producing revenue. The one I want to talk about today is called dialed access location, and this is the 125. This is our 125, and it allows the subscriber to dial 125 bank, and they can be connected to the nearest bank automatically. Or you can also dial 125 SMS bank and get the address of the nearest one cent. This application is implemented in 4 classes and 41 methods. Is that right? 41? Yeah, 41 methods. So it's smallish. Our first production deployment for the support Childline was on August 20th, 2009. And to this day, we've not had a single service interruption. So So that's a testament to the stability of Smalltalk. We did receive an upgrade request in 2011. What was happening is there are jurisdictional issues where if this red dot represents the caller, it was the way the awareness engine was routing was by line of sight, or as I've been working on my Biloxi accent, it would be as the crow flies. So it was connecting across the provincial boundary here. This is Eastern Cape, and I believe this is in Pumalanga. It would route across the border in Pumalanga. They would have to transfer the call to this office for various jurisdictional reasons. What they wanted is they just want the call routed to that office in the first place. Seems pretty simple enough. However, when we look at the call detail record, there's no provincial code, just a latitude, longitude. So the core requirement now becomes for any latitude, longitude coordinate, identify the province that contains it. And I was, when I joined this company, it's a very small company, I finally received my Smalltalk dream, or my dream of being able to do things the way I wanted to do. So they put this responsibility on me. I'm in charge. I can do it however I want. But it's not exactly the type of application since 1994 and working in various Smalltalk IT gigs that I was faced with. It's an entirely new domain. I knew nothing about geospatial domain, and so I was suddenly faced with all these options that I can choose from. Call as ESRI or interface to an external system. Maybe that might be worse than trying to do it yourself. You know, we all like to keep everything in Smalltalk. Use a web service. Maybe Google has a lot of mapping information, or learn and develop my own. Failure's not an option. This is kind of how I felt at the time initially, like I was being squeezed in a vice because of the pressure. So I decided to bring to bear Smalltalk. One of the very first things I found was a database, a free, which is a names hierarchy of geographical names and features and populated places with a latitude, longitude. Hey, maybe this can help me. At the time I was thinking of the cities in each, down to each municipality, I think. There's continent, country, province, municipality, and then these points, which were just the cities. So geonames.org has this. You can go out and download it. This is the model that I built, very simple. This reflects their model. So the main root class is a geolocation, and that can be represented as a region or a point. The point is the city, and this chord here is the latitude, longitude of the center of the city. The georegion would be the municipality that has a collection of those points. Now this polygon here that's not part of the GeoNames data set. I added that to my Smalltalk model later on because I figured out that I couldn't meet the requirement by simply only using the collection of points. So I built that big names tree, and I wanted to be done, but of course I wasn't, because here, this particular region is Gauteng in South Africa, and it's the smallest province, but the one that's the most populous. These little circles within this region represents the latitude, longitude positions of those points on those georegions. And so because of the shape here, if the caller was where this red circle is, and I tried to do some algorithm where it was the closest to each one of those, it actually would pick Gauteng instead of the adjacent, where it really is. So it just wouldn't work. That's what I wanted to do at first. So I was back to, I started, but I still had to solve the real problem. So thankfully, Brent pointed me to another website which had free public domain data called Map Library. And it had the polygon data, coincidentally, for only Central America and Africa at the time. Now it's the whole world, but it's, I believe, only in certain formats for areas besides those two continents. The model that I chose to do was KML. KMZ is a zip file of KML, XML data. KML is Google's model, and I just chose it simply because I went there, I read the documentation, it was very easy to understand, so I went ahead and built this KML domain, and this mirrors Google's KML model. At the root, you have a KML geometry, which has a rectangular bounds. A points container is for representing things within a particular geometry, a polygon. The linear ring is actually a mathematical polygon, but the KML polygon can have an inner boundary. So all polygons have an outer boundary, but South Africa has completely encircles another country called Lesotho, so that actually was very nicely that Google had the foresight to do that. And line string would be for representing rows and rivers, multi-points and text are for data points and labels and things. And KML multi-geometry allows you to have layers where you can layer on multiple KML geometries, but actually it's a composite hierarchy, so it's even more sophisticated than just a collection of layers. And then KML form is something that I introduced. Because another thing is, if you have some space imagery, and you know the upper left and lower, the latitude and longitude, the upper left and the lower right, then you can superimpose space imagery on that. It also satisfies another use case with this, and that is that, I mentioned the business intelligence system called TEFRA, which I'll talk about shortly. And what that does is, we're plotting points, and as you plot thousands and thousands of points on a single polygon, it ends up being a vector animation that requires a lot of enumeration to render. But when you paint on a form, you can't erase it, but at least as you paint more and more dots, it never really gets much bigger. So it's sort of a storage and computation efficiency to be able to have a KML form. This is the method which I ported from a C code that was in the public domain to Smalltalk. As optimized as I can make it for Smalltalk. This coordinates is a word array, and there's almost nothing but primitives here. But once I reach that point, once again I'm faced with a project unlike I had ever faced before, which is, okay, so I've got all the polygons loaded in the object database, and I've got my little method to test whether a latitude longitude point is intersecting with the polygon. So I was able to pick one or two points visually just by looking at a globe and saying, okay, this point should be in South Africa. And then, yep, it worked. And then I picked one out and it said false. Okay, that worked. But so one thing John Sullivan, the CEO of the company, said when I went to hang with those guys in 2009, he said he doesn't ever want to hear it should work. So I really didn't feel comfortable enough with a few tests, a few points I could pick manually. I needed some way to be able to test many, many thousands of points very, very quickly and have it tell me very quickly whether or not it's in or out of the polygon. And I had suddenly a realization that right here in Sweep is morphic. And with morphic, I could render it, and with its input events that it has, I can just simply move the mouse, and with every mouse movement, translate the pixel to the equivalent translated to the latitude longitude, and tell me yes or no, is it inside the polygon? So even though that was a development commitment, I decided it was worth it. A quick comment about morphic, I really liked it. You get access to a canvas, and with events generated by the keyboard and hand, it handles damage management and frame buffering, and it provides efficiency by letting you have a step time that's only as often as necessary. So I went ahead and did this, and there were many rendering challenges initially, point translation issues that I had to face, but after a few days, I was able to render the polygon. So let me show you really quick. This is the office objects. I'm going to pull up Earth here. I have region name, but you know what? I really just want to show to emphasize the morphic aspect, where rather than this region name method pulls up and wraps it in another naked object. So what I want to do is create another method called KML named a string, and it'll say return. Actually, I don't need to return because I know that it opens in a world self region named A-string. Draw came up. Say that. Let's put it on the GUI. File tongue. Accessing the database. Okay. Close that. And just move this out of the way. Hopefully. So can you see the polygon? Okay, so right now it's testing many thousands of points. They're all returning false. When I go in here, it returns true and indicates that by drawing the crosshair. It also highlights the border. It actually does also change the color of the polygon itself. So I'm able to test these little cases here that are tough to pick out manually, and so I can see very quickly that it's working. So I was very happy. So with that done, I ask, is the requirement now met? The requirement was for we need to identify the region for any latitude and longitude. Unfortunately not. What I have done so far is create a tree of named regions and a tree of polygons, but I never associated the two. So the problem now is how can I get that polygon instance field populated on the georegion? Here's a picture of Kenya. I thought to do it manually at first, and then I saw Kenya and all these subregions. Could I possibly get all these right doing it manually, but I wouldn't even attempt this? Plus, when you have a system, you want to be able to rebuild it by pressing one button. So that was just, manually was unacceptable. Then I remembered, hey, there's that points collection from the GeoNames data set. So if I just found the polygon, use my intersection test method, find the polygon for which all or most of the points intersect, then that should be the one. I say most because some of them are border towns, and they end up on the maybe slightly outside, and so I didn't want it. At first it was failing on that, so I had to do it by most. Okay, so are we done now? Well, now the issue is that this is a telephone system. We have many thousands of calls, and by the intersection test I showed a moment ago, even though it's as optimized as I can make it, in order to describe a polygon as large as South Africa, you have to use a lot of points. So you can't enumerate 10,000 points to ask if it's inside the polygon. One of the things that Brent also taught me is that we could try converting some algorithm to C++ and call out to it, but that kind of muscle gives you about a 3x improvement, where if you employ the power of small talk with algorithms and sophisticated optimizations, you can get a 10x improvement. So we stuck with small talk, and there were three things that I tried to do to optimize the intersection test. The first was very naive. It was just a balance check. When I press B, the pink that you see there represents the balance of that. When I turn on the subregions and press B, we can see that if we bound each one, it ends up, what they provide us is a quick elimination test, but because the rectangles overlay a lot, you end up with having to test 2 or 3 polygons and enumerate all the points to find B1. And you can quickly eliminate one if it's out, but if it's in the rectangle, it may not still be the one. So that ended up not being good enough. Next, Brent mentioned that there are these populated places in the GeoNames data set. So if we treat each of those as the center of a circle that is inscribed within the polygon, then we can cover these regions that are highlighted in blue there by just testing the distance to the point, the center of the circle. If you're within you're inside the circle, which means you're inside the polygon. So that's a quick positive test. We had the bounce check, which is a quick elimination test. This is a quick inclusion test. But still, the problem is that the requirement is we have to, the method is region for this lat long, the lat long. That's the requirement. So if we think about the structure that we have now, we have a hierarchical structure where we have the continents and then the countries, and then they contain the provinces. Well, what happens is if you ever have a call, for every call that's not in one of the circles, then you end up having to test South Africa, which has over 10,000 points. So every call that's in those places is kind of slow. I mean, it's maybe 500 million, 700. It's too slow for a telephone system. So then Brent once again helped me. He pointed me. He said, "Check out C-squares." Now, Johnny T yesterday was talking about having a grid on the globe. He didn't call it C-squares. He called it something else.
GeoHash.
Okay, GeoHash, right. And I think this is a similar thing. It's almost the same thing. It's basically taking a grid, and the main thing that so what you do is when you build the model, you enumerate all these and parse the XML and build it, we calculate all of here's the C-square, turn that off. Here are the C-squares for Gautam. These end up being labels for that we index Gautam at all of these string keys. And that way we can look up Gautam, we can also take lat long and get its 7-digit, or this is 8, I guess, digit C-square code. So what's the main difference is that now we can go straight to the childmost polygon. And that's the optimization that really, in combination with the inscribed circles, ended up being satisfactory. So, okay, I'm making pretty good time. So is the requirement now complete? Yes, finally. We're able to get the correct region identified from lat long. So Brent was then able to update the dialed access location application. The total effort was 13 new methods, 4 changed methods, and he removed 2. And actually only one method was really the main processing method was the one that changed, to do the lookup instead of doing a line of sight. So that, including all his analysis and everything, I looked at his Monticello version is 8 calendar days. So that's how long it took to do that once we had the geospatial domain. So now I want to talk about the final chapter of my talk, which is the using mobile network awareness and aggregating information in order to learn a lot, I guess, about the subscribers. And one of the ways one of the things that's good to know is that when you use your phone to do something like update your Facebook page or make a call, is that there's a ton of information that's really being leaked, I guess. 4 of the 5 W's, they know who you are by your phone number, where you are, they know what time it is, they know, and they can probably infer the 5th from the Y, I guess. And additionally, they also are capturing associations to another party. And so the aggregation of all this information is called context. And the challenge for operators is to make good use of the information. It's a tremendous amount of information. So just some really quick, couple of things that are additional leakages of information. Like if your phone is at the location H for the same 8-hour period each night, it's probable we can infer that you live there. If your phone is not used, no calls are made for the same 8-hour period each day. That could be bedtime, the time that you sleep normally. So even the idea that information could be inferred even when you're not doing anything is maybe something that hasn't been thought about before. So now I'd like to introduce Tephra. And what it does is a data aggregator, also developed in Smalltalk. And its objective is to aggregate massive quantities of facts and here's an overview of the process overview. We take input data, goes into a loader, creates stacked objects which are posted to a data queue, maintains a cell lattice, and then is accessed by clients to provide decision support information. The goal of the system is to identify peaks, patterns, exceptions, and also to visualize the data, and also to be able to define threshold triggers that can generate a notification if they're exceeded. And I'm really excited about this application because it's generic and it's useful not just for telephony, but any domain. Because the schema is an object schema. It's just objects, and you can define any schema you want on the fly. Probably, maybe you know about OLAP master cubes. I did not know anything about them before I started this in two years ago. But Smalltalk, one of the great gifts that Smalltalk has given me is just personal growth. Anytime I try to do something in Smalltalk, it forces me to learn about it, and this was one of the things that I really enjoyed learning about just by working on it. And the main aspects of the OLAP domain are dimensions, levels, positions, addresses, cells, and measures. Dimensions are the variables along which to permute the facts. Levels are each dimension can have one or more levels, and they define the levels at which to permute those facts. And then positions are the data point instances for a level. Addresses end up identifying a bucket, and a cell is where the measures are deposited into that bucket to accumulate totals. Okay, so I've made fantastic time. Every time I rehearse this, I was right at about 40 minutes rather than 30 minutes. So I'm really pleased about that. I was really trying to go fast. So does anyone have any questions so far? Okay. Before I do a quick demo, let me just say the idea that when a young person in South Africa makes a call to that number and they need help, and some methods with my initials on are being executed to help get them in touch with the right person, I can't even imagine a greater privilege than that. The fact that I got to work on something I enjoyed working on in doing that. What could be better than that? So I've got this little cube that I made before talk because, okay, really quick, what this is a Tetra desktop, and you have cubes which are very large cubes which you can connect to over the LAN remotely via the LAN instead of only the user, or the user can define their own cube, and that's what I did here. All the user interfaces you're seeing here, the number of lines of code to implement these user interfaces is 0. They're naked objects. So as I'm going through this, here's one of the accessing methods for a TE application. Here's the schema. It has a name and a UID. Here are the dimensions. I have 3 dimensions: the time, location, and the Childline office that was called. Each dimension has 3 levels. And this is another thing I wanted to point out about the naked objects. I'm sorry to keep injecting this other topic into my main topic, but this is one of the things that kind of makes some of the work I do possible by allowing rapid development. But beyond that, the interface itself that is produced by this rapid development is something that I refer to as very high density. It's functionally dense. If you look at most of the interfaces into traditional or basic applications today, you have a bunch of icons across the top, and then you have this sort of content area in the middle. And what we have with this is I can, with what I call a usage life cycle that is only 2 gestures, I have access literally to hundreds of functions. The 2 gestures are point and then press a button if necessary. Sometimes pointing is enough. And that's one of the things I'm also concerned about with touchscreen interfaces, is that they remove the power of pointing. You can't just point and have something happen. You can only click. But with pointing, it highlights something and it maybe could tell you something. But for each one of these things that's highlighting, there is there's a whole set of hotkeys There's a main context menu and a tool menu. The tool menu is for actually modifying the interface on the fly. There is no studio mode and then runtime mode. It's all live. It's always the studio and the runtime. So anyway, here's the dimensions. Here are the measures. I just have you can define a block closure as a measure, or you can measure any scalar attribute. And the import specification here, once again, I'm going to tear off this, and the number of lines of code to implement this is 0. This is the file pattern I've loaded for this cube is the December of 2011. So this is last December's data. It's a 66 megabyte file. It takes about 10 minutes to load on this 2-core machine. So I think I loaded on 1 core. I think it took about 15 actually. So I don't know what it would be on 2. But then we have. So here's like a representation of the cell hierarchy. This is again another 0 code interface, and it just shows that for all locations, all time, and all MSISDNs, which is the phone number, there were 332,000 calls that month to Childline. And this, I can drill down and based on a time position, a location position. The reason we have other mill here is because there were some that didn't have a lat long that came in, so there's nothing, you can't look it up. And then Swaziland is a neighboring country to South Africa. So we can drill down into some of these. Here's the 800 number, so there's the 555. But what are these other ones? The 12 and the 27. 27 is the country code. So I guess they must have another number here. This 2780. Oh, okay, they dialed the country code. So all this does is just represent the cell hierarchy. I'm looking at one cell at a time. That's kind of a limited view of the data. So if I click this, I can get a spreadsheet. And let's see, I don't need that. And with this, I can look at multiple at a time. And so I'm going to do a filter. I'm going to eliminate, because I only have Polygon data for South Africa loaded right now, so I'm going to filter based on South Africa. So I just drag this out of here, drop it here. It figured out that that's a country, so it does by country equal to South Africa. This little ellipsis here produces an and an or, another naked object, 0 code, and lets me create aggregate conditions. And I can take this, drop it in here, it becomes the query, and so now we only have South Africa. Let me hover over this number and let's click on the magnifying glass to zoom in on that, see the breakdown of this 331,000 calls. Where are they at and on what day? So what it does is it zooms one level down on the time and location dimension. And it looks like it's a little wide here because I've got the time across the top and there's 31. So I'm going to pivot this. I'm going to put time down the left side and location across the top. So I just hover here, click that and it invokes a method. With the naked objects, I can use any bitmap as a label for the method name instead of the method name. So that can make it look better. Okay, so now we have it broken down with the time down the side. So I can look at any individual. I'm looking at multiple cells at a time now. And to integrate the geospatial, here is the calls that were in KwaZulu-Natal. You can maybe see the pink dots. That was the location of the calls, and they're translucent. So the ones where you can barely see them, there were few calls. The ones where they've stacked up on top of each other and it's more pink, that's where there was a higher density of calls. So that provides a visualization that is not obvious by looking at the data. And so the next step, besides looking at it statically, is to be able to look at to visualize the time series data. And the only way I know to do that is via animation. So a standard animation object can be created here to visualize the calls. Let's increase the frame this is the calls for December last year. And I wanted to show the satellite imagery because it looks pretty. There's a trimmed image, and I like the one with a full rectangular image. Well, that's my talk. Any questions? Yes?
Is this open source or is this a proprietary?
No, obviously the awareness engine is not open source, and Tephra is not open source. However, and neither is the GIS module, but the naked objects framework and the object database is. The object database is Magma. So you put that in your suite.
KNL support? KNL?
That? No, that's part of the GIS module. It's, I could ask Brent. I was thinking about asking him because sales has been kind of slow, so maybe eventually we might. But for now, I